Okay, inverse functions. When we're talking about inverse functions, which you did in either Algebra 2 and or pre-calculus, we looked at them from three different aspects. But before we get to those three different aspects, let's talk quickly about the notation. So we're going to say here that G is the inverse of F, okay? As far as the notation is concerned, that means that G is the inverse of F. Here's your notation for the inverse function. It's the function with the superscript of -1. This is not a negative derivative. It's just the symbol for the inverse of F. Okay, now what does that mean? Well, if we're dealing with a function and we're given specific values, in other words, we're given a numeric view of the function, let's throw some values in there. Let's say that x is the very basic 0, 1, 2, 3, 4. And f of x, let's see, f of 0 will be 5, f of 1 will be 2, f of 2 will be -3, f of 3 will be 0, and f of 4 will be 1. Okay, now we want to find the inverse. Do you recall what we need to do when we're given a table of values and we need to find the inverse of the function? Well, let's see, were you correct? The answer is that you swap the columns. All right, so the f of x column will become the x column for the inverse. And the x column, the independent variable for f, will become the dependent variable for g. All right, so what happens? Well, 5, 2, -3, 0, and 1 are now the independent variables, and 0, 1, 2, 3, and 4 are the dependent variables. Okay, what does that mean basically? Well, it means that, for example, f of 1 is equal to 2. f of 1 is equal to 2. But g of 2 will be equal to 1. g of 2 is 1. g of 1 is not 2. f of 1 is 2, but g of 2 is actually 1. If we want g of 1, well, g's value when x is 1, down here, g of 1 is 4. Writing into my graph here, so I have to graph a little differently. Okay, so that's if we have a tabular or a numeric point of view. If we're dealing with graphs, do you recall what happens with inverse functions when we're dealing with graphs? Well, if you answered yes, that means that you remember that the two graphs will be reflections over the y equals x line. Okay, so if we're dealing with, let's say, for example, x cubed. All right, well, x cubed's graph comes up and does a little crisscross with the line there, so that we have that. And the inverse of x cubed will be the cube root of x. What does the cube root of x do? Well, it does this. Oops, I missed it a little bit. Close enough. All right, that is the cube root of x in red, sort of, if I was a better drawer. All right, now what does that mean basically? What it means is that if we were dealing with my superhuman strength and I were able to rip the board off of the wall and fold it over on this broken black line here, the y equals x line, then the green marker would match up perfectly with the red marker and vice versa. They are reflections of each other, so they will match up if we fold the board over on that line. They are reflections over the y equals x line. If we can prove that, then, or if we know that the two graphs are inverses, then that means that their graphs will be reflections over the y equals x line. The most common thing that we think of, the graph of e to the x and the graph of the natural log of x, which I think is on your worksheet. All right, last but not least, the symbolic point of view. F of g of x. What happens when we take the inverse of a function and we plug it into the original function? Well, it's actually the same thing that happens if we take the original function and plug it into the inverse. They will produce a particular value. Do you know what that value is? Yeah, the value is x. Quick example. Two functions which are inverses. F of x is equal to x squared. G of x is equal to the square root of x. They are inverse functions of each other. Okay? So if we plug one into the other, in other words, if we find f of g of x, okay, f of g of x means that we are going to plug g of x, which is the square root of x, for all values of x where it's defined for f, where it's defined for x, I should say. Said that backwards, I apologize. So we have the square root of x being squared. What happens when we square the square root of x? Yeah, they wipe each other out, and we're left with x. That proves that f and g are inverses. So if you plug one function into another, then you're going to get f. Actually, excuse me, you're going to get x, which is good when we want to talk about the derivative.